Hello and welcome one and all to first PU Tungal online classes. In the last class, we were discussing about thermal expansion. That is thermal expansion of solids. In detail we have seen. Thermal expansion means the increase in size of the object due to increase in temperature. That concept we are calling thermal expansion. In thermal expansion, either expansion possible in solids, either liquid or in gases. Already we explained that in solids, thermal expansion is along lengthwise, along area wise and along volume wise. That we are calling in solids. Thermal expansions are linear expansion, areal expansion and volume expansion. Right. In detail we have explained. But in case of gases and liquids, what happens? When heat is provided to gas or liquid, there what happens only volume will expand. Right. In the previous class, we have seen the linear expansion, areal expansion and volume expansion. Already we know that linear expansion means increase in length of the object due to increase in temperature, that we are calling linear expansion, and that formula already we know that. For linear expansion, del L equal to L naught alpha into delta T, or L is equal to L naught into bracket 1 plus alpha delta T. And for areal expansion means increase in area due to increase in temperature. That already formula is there. Del A is equal to A naught into bracket A naught alpha into delta T, beta into delta T, or A equal to A naught into bracket 1 plus beta into delta T. Similarly, volume expansion, V equal to V naught into bracket 1 plus gamma into delta T, where alpha, beta and gamma we are calling coefficient of linear expansion, coefficient of volume expansion and areal expansion, respectively alpha, gamma and beta. In this session, let us see what are the relation between alpha, beta and gamma. Shall we go, students? Today's concept is relation between alpha, beta and gamma. Relation between alpha, beta and gamma, that is coefficient of linear expansion, coefficient of areal expansion and volume expansion. See here, already is there, coefficient of linear expansion is very smaller. It is lying of the order 10 raised to minus 5 to 10 raised to minus 6 per degree Celsius over the temperature from 0 degree Celsius to 100 degree Celsius. Right. To understand the concept of alpha, beta and gamma relation, let us take a solid of the cube. 1 meter cube we will take. Shall we take? See here, I will take a cube. This is a cube I will take. This is the cube. Right. This cube has a definite length. L naught is the origin length. All sides are equal for this. Right. When heat is given to solid, it may expand along lengthwise, along area wise and along volume wise. Right. Shall I see? When heat is provided to this system, I mean cube directly. This is some amount of heat. Right. When heat provided, its length changes. How the length changes? The change in length, L equal to how much? L equal to L naught into bracket how much? 1 plus alpha into delta T, where L is nothing but the increase in length. L is equal to L naught plus del L, or contact directly L is equal to L naught into bracket 1 plus alpha delta T. Alpha, what you are calling alpha? Coefficient of linear expansion for a given solid. This coefficient of linear expansion, already I said that lying from 10 raised to minus 5 to 10 raised to minus 6 per degree Celsius, and it only depends on nature of material and over a wide range of temperature. I mean, as the temperature increase, the L value increase and it is different for different material. Mean the material which has more temperature, it has more coefficient of linear expansion. Right, students? Now in this case what happened? In this case, here L is equal to L0 into bracket 1 plus alpha delta T. Behind alpha, anything is equal to 1 value. Shall I take this? 1 alpha equal to 1. I will call. This is what equation number 1 I will call. Right? This is equation number 2 I will call. Right? To understand the concept of coefficient of aerial expansion or superficial expansion, now square this equation on both sides. Square the equation 1 on both sides. How to take? Square the equation for this actually. How to write the sides here? See here, area of this one, A is equal to what value? A is equal to L square. Because area is equal to length into length here. Or shall I take here A0? What is A0 here? A0 equal to how much? L0 square. Similarly, value how to write? Value B is equal to how much? L cube. Then what about V0? V0 is equal to how much? L0 cube. Because area is equal to length into length, volume is equal to length into breadth into height for this cube. Now, square equation 1 on both sides. What you are getting? L becomes L square. L0 becomes L0 square into bracket how much? 1 plus alpha into how much? 1 plus alpha into delta T whole square. Right thing, students? Again expand this. L square replaced by what value? A. L0 square replaced by what value? A0. This A plus B whole square form. A plus B whole square. What it becomes? 1 square plus alpha square delta T square plus 2 alpha delta T. 2 alpha delta T. Shall I take directly again? A equal to how much? A0. 1 square 1 plus. Look at me. We said that coefficient of linear expansion is very small. Coefficient of linear expansion is very small. Then square of coefficient of linear expansion again very small. I mean it is of the order 10 raised to minus 6 per degree Celsius. Square of this what value? 10 raised to minus 12 per degree Celsius. That's what the term containing alpha square and delta T square is very small. How I am saying? I am alpha ಯಾವ ರೇಂಜ್ ಒಳಗದ 10 raised to minus 6 per degree Celsius ಅದ. ಅದರ ಸ್ಕ್ವೇರ್ 10 raised to minus 12 per degree Celsius. That's what this term alpha square delta T square, it is neglected because it is very smaller. If this is neglected, then what is remaining? See here, 2 alpha into how much? Delta T. Because what happens here? Here what happens? Alpha square delta T square is neglected. Is neglected because it is very small. Then again, how to write this equation? See here, this equation similar to what happened? A is equal to A0. A is equal to A0 into bracket 1 plus 2 alpha. 2 alpha, it is similar to beta. That's what I will take delta T. How this equation looks like? Equation A is equal to A0 into bracket 1 plus beta delta T. Beta replaced by what value? 2 alpha. Shall I call this how much? Equation number 3. Then what happens here? 2 alpha is replaced by 2 alpha is replaced by beta. Here 1 alpha is there. Equation number 2. Shall I call this equation number 4 now? Because A is equal to A0 into bracket 1 plus 2 alpha delta T. 2 alpha replaced by beta. What is beta here? Beta represent coefficient of aerial expansion or superficial expansion. Now again we need to find coefficient of volume expansion. How to do? Look at me. Cube equation 1 on both sides. Cube equation 1 on both sides. What we are getting? We are going to cube in. L becomes what value? L cube. L0 becomes what value? L0 cube into bracket 1 plus alpha delta t whole cube. Right. Now V equal to L cube, V naught equal to L naught cube. Shall I take L cube replaced by V, L naught cube replaced by V naught. See here, what form this is? A plus B whole cube form. A plus B whole cube form. How to write? A plus B raised to cube equal to A square A cube plus B cube, A cube plus B cube plus 3 A square B, A replaced by 1, B replaced by 3 A square B plus 3 B square A, 3 B square, B replaced by alpha square delta t square into what form this is? A plus B whole cube form. A cube plus B cube plus 3 A square B plus 3 B square A. B square A. Right. But already is there. Alpha is very smaller. Alpha square, it is again very smaller. That's what in this equation, whatever the term containing alpha square and alpha cube, those are neglected. ನಾವೇನು ಮಾಡೋದು ಇಕ್ವೇಷನ್ ಒಳಗೆ ಅಲ್ಫಾ ಬಹಳ ಸ್ಮಾಲ್ ಇರ್ತದೆ, ಅಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಮತ್ತೆ ಬಹಳ ಸ್ಮಾಲ್ ಇರ್ತದೆ, ಅದಕ್ಕೆ ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ದೀವಿ. ಅಲ್ಫಾ ಕ್ಯೂಬ್ನು ಅದಕ್ಕಿಂತನೂ ಸ್ಮಾಲರ್ ಇರ್ತದೆ. ಸೊ ವಾಟ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ಹಿಯರ್? ವಾಟ್ ಎವರ್ ದ ಟರ್ಮ್ ಕಂಟೈನಿಂಗ್ ಅಲ್ಫಾ ಕ್ಯೂಬ್ ಅಂಡ್ ಅಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಆಲ್ ಆರ್ ನೆಗ್ಲೆಕ್ಟೆಡ್. ದಿಸ್ ಇಸ್ ನೆಗ್ಲೆಕ್ಟೆಡ್ ಬಿಕಾಸ್ ದೀಸ್ ಆರ್ ವೆರಿ ಸ್ಮಾಲರ್. Then what happens here? What is remaining then? V is equal to V naught into bracket 1 cube 1 plus this is neglected, this is neglected. What is remaining? 3 1 square 3 alpha into how much? Delta t. Right. How this is similar? This is similar to what happened? V is equal to V naught into bracket how much? 1 plus gamma into delta t. Shall I call this equation number 5? Here gamma equal to how much? Gamma is similar to 3 alpha. Gamma is similar to 3 alpha. From this what you are getting? From this. What about this equation number 6? Students, what you got? From equation 2, from equation 4 and from equation 6. Here what happens is that here alpha is there equation 1. Then what about equation 4? 2 alpha is there. What about equation 3? 3 alpha is there. Right. Then alpha, beta and gamma. What about this? This we are calling 1 alpha. This is alpha. What about this? This is beta. What about this? This is gamma. Right. Then alpha, beta and gamma. What ratio they are lying? Alpha, beta and gamma. Alpha, beta and gamma they are lying in the ratio 1:2:3. 1:2:3. I mean coefficient of linear expansion if it is 1, then coefficient of aerial expansion 2 times of alpha. Similarly coefficient of volume expansion 3 times of alpha. That is the relation between alpha, beta and gamma. What about this? 1:2:3. But students, we need to study some relations concerned to alpha, beta and gamma. Some more few relations regarding what? Alpha, beta and gamma. Before that, we should know about coefficient of linear expansion, coefficient of aerial expansion and coefficient of volume expansion. Shall I say here? Alpha, beta. Remember alpha, beta and gamma, how they are lying? They are lying in the ratio 1:2:3. See here. What relations we got now? Alpha, beta and gamma. Right. See here. What relation we got in between alpha, beta and gamma? See here, alpha, beta and gamma. gamma. How they are lying? They are lying in the ratio 1:2:3. Right. But students, you can write this. You can write this relation like this. How to write? Gamma equal to alpha plus beta. Gamma equal to alpha plus beta, because gamma is 3. Gamma is 3 equal to alpha is 1, beta is 2. 1 plus 2 equal to 3. This relation I got. This is the one relation. Then for beta, alpha and gamma, we want to see in terms of length relation. Students, before that we know that for coefficient of linear expansion, coefficient of areal expansion and volume expansion, already we have seen how this is. For linear expansion, already the change in length equal to how much? L0 alpha into delta t. Right? Or from this how to write? Similarly for areal expansion, how to write? Del A is equal to how much? A0 beta into delta t. Right? Similarly for volume expansion, del V is equal to V0 gamma into how much? Delta t. Right? This is coefficient of linear expansion, areal expansion and volume expansion. Now students, from this equation how to write? From this equation alpha how to write? Alpha equal to del L divided by how much? L0 into delta t. Shall I call this equation number 1? Right. Now for coefficient of linear expansion, how to represent fractional change in length? ನಮಗೇನು ಬೇಕು? Fractional change in length. How to represent fractional change in length? See here, look at this relation. Del L equal to L0 into alpha into delta t. This ratio, change in length divided by original length equal to alpha into delta t. Right? Del L divided by L0 equal to alpha into delta t, where del L change in length divided by original length is nothing but fractional change in length. ನಾವೇನು ಕರಿತೀವಿ ಅದಕ್ಕೆ? Fractional change in length ಅಂತ ಕರಿತೀವಿ. See here, shall I call this equation number 2? This fractional change in length also you can represent in some other way. Look at equation 1, alpha equal to del L divided by L0 into delta t. Then shall I go? Del L divided by L0 equal to alpha. How to represent alpha? Del L into delta t whole divided by L0 into how much? Delta t. Where alpha is equal to del L. Like this you can represent. Again this del t get cancelled. What is remaining? This only remaining. Right? Similarly, this is for what? This is for coefficient of linear expansion. Coefficient of linear expansion. Similarly, you can represent fractional change in area in this case. In this case, how to represent fractional change in area? Shall I take students here fractional change in area in this case? Del A is equal to L0 beta into delta t. Shall I take now? Del A divided by how much? A0 equal to beta into delta t. This is what they are calling fractional change in area. Fractional change in area of the given solid. But again beta, what is beta? Beta equal to 2 alpha. Beta equal to 2 alpha. See here, what are calling this? 1 alpha, this is 2 alpha, this is what value? 3 alpha. Right? Alpha, beta and gamma. How to represent directly again? Del A divided by A0 equal to 2 alpha into delta t. Right? Because beta equal to 2 alpha. Shall I call this equation number 3? Now look at equation 1. Alpha equal to del L divided by L0 into delta t. Alpha another. Then fractional change in area ಹೆಂಗೆ represent ಮಾಡಬಹುದು? Del A divided by L0 equal to alpha. What is alpha? Del L into delta t whole divided by L0 into how much? Delta T. Delta T get cancelled. Then how to represent fractional change in area? Del A divided by L0 equal to 2 del L divided by L0. 2 del L divided by L0. What about this? Again alpha into delta T. This is fractional change in area. You can represent like this. Shall I call this equation number 4? Fractional change in area. Similarly, fractional change in value, how to represent? Look at me. How to represent fractional change in value? See here, del V equal to V naught, or how to write? Del V divided by V naught equal to gamma into delta T. Fractional change in value, right? But gamma equal to how much? Gamma is 3 alpha. Hang baribodu. Del V divided by V naught equal to 3 alpha into delta T. But again look at me. Shall I call this equation number 5? No. Alpha is there from equation 1. From equation, what is alpha? Del V divided by V naught equal to 3 into alpha. Alpha means del L divided by L naught into delta T. L naught into delta T. Delta T get cancelled. Then again how to write? Del V divided by V naught equal to 3 into del L divided by L naught. This is the relation. Equation number 6 we can call. I mean the fractional change in length, fractional change in area, fractional change in value. This we are calling fractional change in length. What are calling this? Fractional change in area. This we are calling fractional change in value in terms of length, area and value. This is what? Some relations between alpha, beta and gamma. Students, after this we will see the one more concept. Concept is variation of density of solid with the temperature. That concept we will see. Variation of density of solid with the temperature due to thermal expansion. Right? Look at me here. Variation of density of solid. Variation of density of solid with the temperature. Variation of density of solid with the temperature. Very simple. Just I want to confirm you. When heat is provided, the object get expanded, solid get expanded. In solid, when heat is provided, 4 possibilities are there. First is the temperature of the body changes. First thing, whenever temperature changes, its length changes, area changes and volume changes. One more possibility. When temperature increase, density also changes. How density changes? Already is there. Look at me. We know density formula. Density is equal to what value? Mass divided by volume. Right. Whenever heat is provided, length changes, area changes, volume changes. But remember this point, in solid, whatever amount of heat provided, whatever the range of the temperature, the mass of the solid always remains same. Mass remains same because how much temperature increase, only length changes, area changes, volume changes. What about density here? When heat provided, temperature increase, volume expand. Volume increase, whenever volume increase, what about density? Density must be decrease. But what about mass? the mass of the solid remains same due to increase in temperature. This quantity remains same. Then now we will discuss in detail how much density changes as increase in temperature. Already got what you got. When temperature increase, volume expand. ಯಾವಾಗ temperature increase ಮಾಡ್ತಾರೆ volume expand ಆಗ್ತದೆ. ಯಾವಾಗ volume increase ಆಗ್ತದೆ density ಏನಾಗ್ತದೆ decrease ಆಗ್ತದೆ. ಹಾಗೆ mass ಏನಾಗ್ತದೆ ಅದು ಸೇಮೇ ಇರ್ತದೆ. ನೀವು ಮೊದಲಿಗೆ ಎಷ್ಟು ಹೀಟ್ ಮಾಡ್ತೀರಿ ಆಮೇಲೇನೋ ಅಷ್ಟೇ ಮಾಸ್ ಇರ್ತದೆ ಫಾರ್ ಸಾಲಿಡ್, ನಾಟ್ ಫಾರ್ ಲಿಕ್ವಿಡ್. ರೈಟ್. Now let us take how density of the solid will change due to increase in temperature. To understand this concept, again we will take the cube, a simple cube I will take. Look at it. Shall I take the cube here? This is the cube. Right. This is the cube I will take. It has length L0, this is the length L0, this is the length L0, all sides are equal. Right. When heat is provided, then what happens? Look at me, I want to provide some amount of heat. See here, I want to provide some amount of heat to the solid. Then what happens? When heat is provided, its volume changes. We know the change in volume. What is the change in volume? Change in volume can be represented. V is equal to how much? V naught into bracket 1 plus gamma into delta T. Shall I call this equation number 1? That is final volume is equal to initial volume into bracket 1 plus gamma into delta T. Right. But we know density formula. What is density? Density is equal to mass divided by volume. Mass divided by volume. Then what is volume from this? Volume is equal to much? Mass divided by density. Mass divided by density. Here always mass remains same. Here how the temperature changes? Temperature changes from initial to final temperature. I mean temperature changes from T0 to T. Remember this point. See here. For this how to write? For this V nothing but final volume. So I will represent volume is equal to mass by density. This is mass divided by density. How to represent? This is what value? Theta. Theta. I will take. Theta means phi r. Shall I take density at what temperature? I will take T temperature. T temperature. Because it is final value equal to. For this how to write? Always mass remains same. This is how to take. This is T0 I will take. T0 means initial temperature. Into bracket. What happens? 1 plus gamma. 1 plus gamma into delta T. Now this mass get cancelled because when heat is provided, once again I am saying, when heat is provided, temperature changes, length changes, area changes, along with volume also changes. But what about mass? Mass of the solid always remain same. Keep it up in mind. So mass get cancelled. What is remaining here? T. Temperature, density at temperature T. This is what? Density at temperature T naught into bracket 1 plus gamma into delta T. Reverse how to write? Reverse of this. This is equal to density at temperature T denoted by density at temperature T naught divided by how much? 1 plus gamma into delta T raised to 1. Anything is there? 1 value. Shall I solve this? How to write? Delta T equal to density at temperature T naught goes upside. What happens here? 1 plus gamma into delta T raised to minus 1. 1 plus gamma into delta T raised to minus 1. If it goes upside, minus 1. Expand this 1 plus gamma delta T raised to minus 1 by binomial theorem. Gamma is very smaller. If gamma is very smaller, then by binomial theorem this equation becomes now. Shall I write this equation? This equation delta T is equal to delta theta naught into bracket 1 minus gamma into delta T according to binomial theorem. I mean when heat is provided, density of the solid changes. Density of the solid changes as a function of temperature. How much density changes? Density at temperature T equal to density at initial temperature into bracket 1 minus gamma into delta T. The ratio of a change in density, how to write? From this equation, ratio of a change in density equal to density at temperature T divided by density at temperature T naught is equal to how much? 1 minus gamma into delta T. This is what? The change in density or ratio of a change in density as a function of temperature. I mean, here simply is there, whenever heat is provided, temperature changes. Whenever temperature changes, it get expand, solid get expand. Solid get expand means its volume increase. Whenever volume increase, wherever volume increase, the density must be decreased. Change in density can be given this formula. A ratio of change in density can be given temperature, density at temperature T divided by density at temperature T not equal to 1 minus gamma into delta T. So these are what? Thermal expansion of solids. Students, onwards we will see application of thermal expansion of solids. I mean, when solid get expand, it has lot of application. Those applications we will see in the next class. That is applications of thermal expansion of solid. Thank you, students. We will continue in the next class.